Hello, my name is Michael Roble and I am owner of 412 BIM Solutions. I have spent 30 years in the industry working for every business unit from municipal to steel mills to oil and gas, and these videos are my way to show people of various levels how to use Revit and even toss in lessons learned from projects over the years. With that said, let's get to it. Hello, in this video we'll be talking about walls, one of the most fundamental elements in Revit. While walls might seem simple at first glance, things can get surprisingly intricate when it comes to justifications and how they influence wall behavior throughout the course of your project. Understanding and applying wall justifications correctly is key. It's not just about making edits easier, it's about setting up your walls in a way that supports your design intent and keeps your workflow efficient as the project evolves. Walls in Revit are system families, which means they aren't stored as standalone RFA files and can't be loaded like component families. To bring wall types into your project, you'll need to either copy-paste them from a container file where you've saved all your standards and types, or use the Transfer Project Standards tool to import them from that same file. The copy-paste method gives you some control. You can selectively bring in only the wall types you need, while with Transfer Project Standards, you get them all. They don't even prompt you. The one key difference, though, is with Transfer Project Standards, they will overwrite your existing types in your destination file if they share the same name. The copy-paste method will not overwrite. Instead, it appends the incoming type to have a 1 as a suffix, which in time that can cause clutter and potentially confusion in your project file. You can access the Wall tool from two different locations. You can go to the Architectural tab and you can access the Wall tool here. You can go to the Structural tab and you can access the Wall tool here. Either one of them, they feed from the same system families. Structural walls are different than the architectural walls because the structural walls have analytical components within them. They can host reinforcing, and it offers cover settings for that reinforcing. These walls are essential for structural analysis and coordination. They also behave different when you're placing them, as when you place a structural wall, the default behavior is to build by depth. So it top constrains to the level that you're on, and you could either set a static depth or you can constrain it to a level down below. You can toggle that to height, but the default is depth. With architectural, it's different. Obviously you don't have the analytical components, but when you go to place one, they want to bottom constrain to the level that you're on, and they default to height. So you can put a static height or you can constrain it to a level that's up above. Either way. Something important to note. Architectural walls will not appear in views that are set for the structural discipline. So if you're working in a structural plan or section, make sure you're using the correct wall type, or adjust your view settings accordingly. I'm going to touch more on that when I get into the interdiscipline coordination videos. I'm going to create a 30 by 20 CMU building with a floor, with a foundation, so I can show you the behaviors between an architectural wall and a structural wall. We're going to start by going to the Architectural tab and click on the Wall tool. Now you're in the middle of placing a wall. You have over in your dialog box, you have your opportunities here to set your justification. Wall centerline, course centerline, finish face, all those. You can actually set your constraints. Right here it's set for unconnected. It's just saying I want a 10-foot high wall. You can toggle that to go to my level at 10 feet, and it'll do that for me. You can make sure this is set for 0, which I think it defaults to that. If you look at the type, we have 8-inch CMU insulation and brick, and there's air gap and there's all that. you could see a lot of that same stuff up here too. So with the sketch boundary here, there's different ways you can do it. You can put it in by lines, you can put it in as a rectangle, polygons, circles, splines, ellipses, everything. If you put them in with line, the benefit to that is you have a little more control to type in what you want. If I click on here, you can see I'm on the inside face of the wall. I could type in 30. I can go down here and type in 20. If I go over to here, it will line up with itself. And now I can close it off. So I was able to put it in using the line tool and typing in numbers. The other option for a wall is to use a rectangle. If you're using a rectangle, if you start at the top left and go down to the bottom right, you'll find that your justifications are all on the inside. The same thing holds true if you go from the bottom right and go up to the top left. If you were to try to go from the bottom left and go up to the top right, it puts the CMU on the outside. And same thing if you go from top right to bottom left, it puts them backwards. But as you can see, this one says it's interior face, this one says it's interior face, but it's really not. So that's where some of the confusion can come up. So the reason why the justifications are very important is for when your design changes. So right now we've established that we needed a 30-foot by 20-foot CMU building. Now if somebody decides they are going to use 12-inch CMU versus 8-inch CMU, if you were to change this, your 30 by 20 hold and everything grows towards the outside. That is the kind of stuff you want to aim for. So before I start placing the foundation walls, I drew in a floor, and I'm going to show you the impact of these being architectural walls. So as you can see, there's a toggle right here that I can make this a structural wall if I wanted to. The impact of them not being structural walls is if you go over and you set your view discipline for structural, you'll see those walls go away. If I undo that, if I grab all these walls and set these for structural, and now if I set this here for structural, the walls are still visible. That is the toggle back and forth between the architectural versus the structural. So I turned the CMU walls back to architectural so they weren't appearing in here. I'm going to start working on the structural walls for the foundation. So now if I go to the structural tab and I can click on wall tool, now as you can see, it wants to look at depth by default, not height. You can change it to height, but depth is fine. I'm going to constrain it to the level at -3 feet. I want to set the finished face for exterior. And the reason why is because I want it to stay in line with this outside of this floor, but if it ever grows, I want it to grow towards the inside. So now what I'll do is I'll make sure it's set for 12-inch concrete. I can hit rectangle, and as long as I start from the top left and go to the bottom right, it will work. Now if I go to the 3D view, you can see the wall in place. Now one thing I do recommend is cutting the tops, putting the offsets back on the top to be negative whatever the floor is. So if that's a 12-inch thick floor, what I'll do is I'll hit tab and select. I'll go up to here and I'll say -1 foot, and that will pull it down. At some point you're going to need to join the materials, but that's a topic for another day. Thank you for watching my video. Be sure to like and subscribe. There'll be a lot more videos coming.